Good evening. Welcome back to AP Stats Notes Online. Want to talk about, so over the weekend we talked about linear transformations. What happens to the mean, standard deviation, and even a little bit about the variance when we transform our data, add or subtract, multiply or divide by a constant to our random variable. And today I want to talk a little bit about what happens if we combine two random variables. And so we'll use these spinners to help sort of iron that out. So we've got two spinners, spinner A and spinner B. And we're going to play a game in which you spin both of them. And then you're going to move the sum of the two numbers that come up on the spinner, right? So let's go through and do some calculations. Well, first of all, in the first spinner, spinner A, the probability of getting a 1 is a half, and the probability of getting 2 is a half, right? In spinner B, the probability of getting any of these numbers is going to be a fourth. All right, let's go through and find the mean and standard deviation of these. And I'm going to continue to use my calculator. Not that this would be very difficult to do by hand, but it's good practice, right? So a couple of lists. I'm going to clear this out. On the first one, I can get either a 1 or a 2, and the probability of either one is a half. So I'm going to create my lists as such. And then the other spinner, I can get a 1, a 2, a 3, or 4, and the probability of any of those is a fourth, or 0.25. Okay? Now, I want the mean standard deviation of each. So I go to Stat, Calc, and then do one variable stats. And so for the first spinner, my values are in list 1. My frequency, which is how often they should occur, which is the probability, is in list 2. And so I hit enter, and there you go. So the mean is 1.5, and the standard deviation is 0.5. Okay? So, and a board that works would be helpful. So the mean was 1.5, the standard deviation was 0.5. Now, let's go find the mean and standard deviation for the second spinner. So I go to Stat, Calc, one variable stat. Now my values are in list 3. How often they occur is in list 4 in terms of their probability. And there you go. The mean is 2.5 and the standard deviation is 1.12, and we can round that. Okay. Now, list all the possible sums for the two spinners. So I'm just going to list all the possible outcomes, and then we'll sum them up, right? I could get a 1 and a 1. I could get a 1 and a 2. I could get a 1 and a 3, or a 1 and a 4. Or I can get a 2 and a 1, a 2 and a 2, a 2 and a 3, and a 2 and a 4. So, sum here is 2, this is 3, this is 4, and this is 5. This is 3, this is 4, this is 5, and this is 6. Now, I need probabilities attached to those. So what's the probability of me getting a 1 and then another 1? So it would be a half times a fourth, because these two spinners should be independent of each other, right? 1/2 times a fourth is going to be 1/8, right? And then actually that's going to be the case for all of these, right? Because if I do a half times the probability of getting a 2, it's going to be a fourth, so it's going to be 1/8, 1/8. It's going to be 1/8 all the way down. Okay? So, now, are any of these sums the same? Well, there's a 2 here, which is all by itself, so no, we'll leave it as an 1/8. There's a sum of 3 here. There's 2 different ways that can happen. So I can get a 1 and a 2, or a 2 and then a 1. And so since either one of these are going to happen, this probability just becomes 2/8 or a fourth. So I'm going to list out the sums here. I could get a 2, I could get a 3, I could get a 4, I could get a 5, or I could get a 6. And that's it. So these are all the different sums and their probabilities. We're creating our probability distribution, right? So there's a 1/8 chance of getting a 2. There's a, like I said, there's two different ways we can get a 3. 1/8 plus 1/8 is 2/8. So I'm just going to make this 2/8 or 1/4. To get a 4, there's two different ways that's going to happen. 1/8 and 1/8 is 2/8, so 1/4. Two different ways I'm going to get a 5. So 1/8 and 1/8 is 2/8 or 1/4. Only one way I'm going to get a 6, and so that just becomes a probability of 1/8. Now, before we go find the mean and standard deviation here, I want to back up and talk about the variances too. Because things are going to be easier to see if we also include the variances. And we did this for just our linear transformations too, if we're just going to do some constant work to our random variable. So if I square the standard deviation here, I get 0.25. Okay? And if I square the standard deviation for the second spinner, I'm going to go find the precise value for that variance. It's going to be 1.25. And you're going to finally see why we keep holding on to this idea of the variance. Okay? All right, so here's our probability distribution for our sums. Now, to find the mean, we'd have to multiply these values, these values, these values, these, and add them all up. Again, I'm going to do this quickly in terms of a list. So I need a second set of lists. So I'm going to use 5 and 6. So 5, I could get a sum of 2, 3, 4, 5, 6. The probabilities are as follows: 1/8, 1/4, 1/4, 1/4, 1/8 for 6. So 0.125. Oops, too many points. 0.125. Okay. Now I'm going to go hit my one variable stat and find the mean and standard deviation. So stat, calc, one variable stats, list 5, list 6, and there you go. Your mean is 4, standard deviation is 1.225. Okay? So let's write that in. So the mean was 4, and standard deviation was 1.225, basically. My question is, what's the variance for adding these two guys together? Okay? Now, to see that, I want to take the standard deviation and square it, right? I'm going to do this as accurately as possible. So since I did a calculation, sigma sub x is stored in my calculator. And it's stored under your variables, right here, vars. You go down to statistics and grab sigma sub x. It'll take that sigma sub x and square that for us and show us that the variance is actually 1.5 without any rounding issues. So this is 1.5. Okay? Now, what do you notice about the mean and standard deviation of the sums? And I'm going to include the mean and standard deviation and variances of the sums compared to the means and standard deviations of the separate spinners. Well, again, the mean here is 4. The mean for A was 1.5, and the mean for B is 2.5. Do we recognize that all we're doing is adding those two means together? Right? So 1.5 plus 2.5 is 4. Okay? Well, that's interesting enough. I wonder if that works for the standard deviations. 0.5 plus 1.12 is 1.62, which is not what we get down here. So it doesn't quite work like that. Look at the variances. The variance for A was 0.25, and the variance for B was 1.25. Look at the variances look at the variance when we add the two together. You see it? It's 1.5. So apparently the adding deal here doesn't work for standard deviation, but it does work for the variances. Okay, so, well, we'll do it this way. So 1.5 does indeed equal 0.25 plus 1.25. Okay, now, how does that relate to standard deviation? Let's do a little bit of algebra work, right? What this right here tells you is that the variance for when you add the two spinners together is equal to the variance on A plus the variance on B. Now, if I want to find the standard deviation for adding the two spinners together, what do I have to do to the variance? Well, hopefully you're saying to yourself, square root it, because that's what we've been doing all along. If I square root this side, I have to square root this side. Okay? And if you look at the top of this page, it says something to the effect of, why do variances add? The Pythagorean theorem of statistics. Well, I just showed you why the variance is added, right, in terms of this situation. And why it's called the Pythagorean theorem of statistics, well, look at it. This should remind you of the Pythagorean theorem, right? A squared plus b squared equals c squared. Okay? Which, don't get me started on that, because it's a terrible way to remember Pythagorean theorem, but whatever, it's what we do. So we get this Pythagorean theorem thing, okay? And this comes about when we combine two different random variables. If we just transform one, if we just want to multiply all, all of our values for a random variable by a constant, or add a constant to all of them, then we get our rules from before. Everything follows, right? Mean is affected, standard deviation is affected a certain way, and so is shape. Okay? When we combine two different random variables, things get a little bit different. Okay? So our means just add, and our variances just add, and our standard deviation becomes this Pythagorean theorem looking thing, and that becomes our rules. Okay? And so I'm going to skip down, and it says rules for adding and subtracting independent random variables. Well, those rules become, at least for adding so far, what we've got is, if I want the mean for combining two random variables, I'm just going to add them individually. And if I want the standard deviation or the variance, I'm going to keep talking about this in terms of variances. I'm just going to add the variances. Life becomes easier when you know you're combining two random variables to think about this in terms of variances. If you know you're combining two random variables, then square your standard deviations individually and add them together. Okay? But if you want to look at this in terms of standard deviation, it's the Pythagorean theorem looking thing. Okay? So that's if we add. Now, let's take a look at if we subtract. Okay? All right. So now we want to, there's a different version of the game where you spin, and we're going to take the difference of the two spinners, and that's how you're going to have to move, right? So if you look up at the top, right, what do we got? We got 1 minus 1, 1 minus 2, 1 minus 3, 1 minus 4. Then we got 2 minus 1, 2 minus 2, 2 minus 3, 2 minus 4. And so, again, all of these are going to be an eighth, right, just like before, because we're combining the two values. Okay? Now, what are all of our possible differences? Well, 1 minus 1 is 0, so I'm going to list 0 here. 1 minus 2 is negative 1. I'm going to probably reorder these if you want to wait. 1 minus 3 is negative 2. 1 minus 4 is negative 3. And then we go 1 here, 0, negative 1, negative 2. So actually, all of our possible values will be 0. We can go this way. 1, 0, negative 1, negative 2, negative 3. Now, all the probabilities involved here. Shoot, didn't want to do that. Okay? Well, yeah, we could do that. Okay, how do we get a 1? Well, there's only what? There's one way to get a 1. And that's if we subtract 2 minus 1. I can write these out. Might be easier to see this way. Only one way to get a 1. So the probability of getting a 1 is just 1/8. So this is A minus B in their probabilities. How about a 0? I can get a 0 this way or this way. So 1/8 plus 1/8 is 2/8 or 1/4, and you're going to see sort of a pattern here. Negative 1, I can do that 2 ways. 1/8 plus 1/8 is 2/8 or 1/4. Negative 2, there's 2 ways to do that. 1/8 plus 1/8 is 2/8 or 1/4. Negative 3, there's only one way to get a negative 3, and so that's 1/8. Now, we need the mean and standard deviation for this situation. So let's take a look. Okay? Again, I need to create my lists. I'm going to use list 4, list 5, and list 6 again. So now my values are 1, 0, negative 1, negative 2, negative 3. But if you leave the probabilities alone, you're going to be fine as long as you list your values that way. 1, 0, negative 1, negative 2, negative 3. Because as you see up here, the probabilities are bookended by 1/8, and they're all 1/4 in the middle. And if you look at your list, it's the same way. So let's just go grab your one variable stats and see what happens. List 5, list 6, we're in good shape. You hit enter, and boom. The mean for this is negative 1, and the standard deviation is 1.225. So the mean is negative 1, and the standard deviation is 1.225. Now, if you just compare this to when we added them, 1.225 squared, like we did before, was 1.5. Right? It's the same deal. But the mean changed a little bit, right? Where did the negative 1 come from? Well, the mean on A was 0.5. I'm pretty sure, right? Is that right? 0.5. No, 1.5 and 2.5. So the mean on A was 1.5, and the mean on B was 2.5. Now, how do you put those together to get negative 1? You just subtract these guys, right? This is 1.5 minus 2.5. So, if I'm going to subtract two random variables from each other, then the new mean becomes simply subtracting the existing means of each individual random variable. Standard deviation or variance, look here, it didn't change from when we added. We still have to add the two individual variances and square root them to get to the 1.255. This is the same as adding. So it doesn't matter if we add or subtract our two random variables, we're going to get the standard deviation the same way. It's the Pythagorean theorem looking thing. Okay? The mean is the only calculation that really changes. And so we can add this into your notes here. So what do you notice about the mean standard deviation of the sums, of the differences compared to the mean? Oh no, this is differences. So the sums and differences. What do you notice about how the mean standard deviation of the sums compare to the mean standard deviations of the differences? Well, again, we've got our rules for adding, but apparently when we subtract, we switch over and subtract the individual means. That's a rough look at mu. But when we want the variance, it doesn't change from adding. We're going to add the variances here. So it's an important distinction here. And then, of course, the standard deviation becomes this Pythagorean theorem looking thing. Okay? So we've developed some rules for when we subtract two random variables as well. And those rules are, all right, so these are your adding rules, your subtracting rules. Become exactly what we just wrote down. I'll put them down here in the same space. If you don't want to rewrite them, you don't have to, but I will. Variances still add. And then, of course, standard deviation just becomes a matter of square rooting your variances, which turns into this Pythagorean theorem looking thing. Okay? All right. So hopefully that makes a lot of sense. Now let's just put it into practice. Okay? All right, so let's head to the next page and do some practice. We didn't really talk about shape, so I'll just do it on this side. Oh, by the way, shape's not going to change either, okay? It didn't change for linear transformations. It's not going to change when we combine two random variables, and we need that when we start talking about normal continuous random variables in terms of density curves and the normal curve in particular, right? So for example, this guy. Suppose that the height m of male speed daters follows a normal distribution with a mean of 70 inches and a standard deviation of 3.5 inches, and the height f of female speed daters follows a normal distribution with a mean of 65 inches and a standard deviation of 3 inches. Never mind about speed dating. If you don't know what speed dating is, you can always watch the movie Hitch or 40-Year-Old Virgin, and you'll see an example of both. Okay? So, here's what we want. What's the probability that a randomly selected male speed dater is taller than the randomly selected female speed dater he is paired with? Again, writing this in terms of symbolic notation is going to be helpful. So first of all, m is height of male, right? And f is height of female. Okay? What are we talking about? If the male is taller, how would we know if the male is taller than the female, besides standing them back to back and just looking? If I just had their heights, how would I know that the male height is, that the height of the male is greater than the height of the female? I'm trying to give you some hints as I talk about it, and that's it, right? We want the male height to be greater than the female height. Or, in terms of something different, if I've got this inequality, how about if I just subtract the female height from both sides? What happens? Well, I get male minus female has to be bigger than 0. And so I want the probability that the difference here is bigger than 0, which should make sense. If the male is taller than the female, when you subtract their heights, it should be positive, right? So that might make life easier once we get into our normal curve, okay? All right. It also shows us that we're subtracting two random variables, m and f. If that's the case, then I need to know, if I'm going to use a normal distribution, I have to know the mean and the standard deviation of this situation here. So I need the mean of male minus female. Well, we just talked about this, right? All we got to do is subtract the means. 70 for the male, 65 for the female. So my new mean is 5 inches, and then standard deviation is the Pythagorean theorem looking thing, where we're going to square the male standard deviation, square the female standard deviation, add them together, and square root them. Okay? So, what do we get? 3.5 squared plus 3 squared. And then we add them together and square root them. We type this into our calculator, right? 3.5 squared plus 3 squared, and then square root 21.25, and we get 4.61. So that's your new mean and your new standard deviation. Again, the shape's not going to change. So if we were normal going in, which we were, then we're going to be normal coming out. And so since we're normal, I'm going to sketch a normal curve where the new mean is 5 and the standard deviation is 4.61. So that means that this guy out here is going to be 9.61. Then we go to 14.22. And then we go 18.83. And you can check my quick mental math on that. I made a mistake, I think, on the notes the other night. But anyway, it happens on occasion. So this is going to be 0.39. Subtract 4.61 from 0.39, and I can't do that anymore. So type it in real quick. Negative 4.22. And then we come out here, we get negative 8.83. Where's 0? I want male minus female to be bigger than 0. Where's 0? Well, 0 is going to fall about right here, right? And so I want that difference to be bigger. This is where all the males are going to be taller than the females. Why is there a negative portion of this curve? Because it is entirely possible for a female to be taller than a male, and therefore the difference be negative. Okay? But right now, I just want to know what the probability of male minus female being bigger than 0. Now, two different ways you can go about this. Okay? Z-score calculation, right? If I want 0, I want to know what the probability of being bigger than 0. I can go 0 minus 5 over 4.61 and get a Z-score of negative 1.08. At which point, I use my table A and go find negative 1.08 in table A. Just because I haven't shown this in a while, I'll do that real quick. Negative 1.08 would put us, negative 1.0 is here, 8 is all the way out here, so it puts us at 0.1401. 0.1401. So, is 0.1401. Remember, that's less than. Table gives us less than. I want more than, so I got to subtract from 1. That gives us 0.8599, I think. That sounds right. So the probability is about 86%. Okay? And if you're doing your calculator normal CDF, you'd put 0 in and then some big number, 100 or 1,000, and then type in 5 and 4.61 for your mean or standard deviation. Okay? And you should get pretty close to the same thing. Now, I do want to talk about the next example real quick because there's a difference. There's a difference between multiplying your random variable by a constant and combining your random variable over and over and over again. So suppose that the weights of a certain variety of apples have weights that are approximately normally distributed with a mean of 9 and standard deviation of 1.5 ounces. If bags of apples are filled with randomly selected 12 apples, what is the probability that the sum of the 12 apples is less than 100 ounces? Now, here's what I want, right? I'm going to define a new random variable, z, right? We can do this. A is weight of 1 apple, right? Which we know the mean standard deviation of. Define z as the weight of 12 apples. The sum, we ought to say that, right? The sum of the weight of 12 apples. Now, it might seem like you would do this. Take first apple, add the second apple, add the third apple, add the fourth apple, all the way down to the 12th apple, which is exactly what we're doing. But a plus a plus a plus a plus a plus a 12 times is not the same thing as 12 times a. Those are not the same. 12 times a means we're going to take the weight of the apples, the mean standard deviation, and multiply it by a constant. And we know how that changes. The left-hand side here means I'm combining the same random variable over and over and over and over again. But we know that when we combine random variables versus performing a linear transformation, that our calculations change. So this is not the same. Do not think that this is the same. Okay? Now, where that 12 might come into play is when we find our new mean standard deviation. If z, I want to find the new mean of z, then I've got to take the mean of A and add it to itself 12 times. Okay? So I got to take 9 plus 9 plus 9 plus 9. Now, this is the same thing. Now we're back to arithmetic. This is the same thing as 12 times 9. It's okay to do that here. Okay? So seemingly the difference between 12a and adding a 12 times doesn't seem to be any different at all. But where the difference comes in is when you go find the standard deviation. Right? We're not going to just take the standard deviation 1.5 times 12. It's not that simple. We have to square root the variance on A plus the variance on A plus the variance on A all the way out and do this 12 times, right? Which would turn into the square root of 12 times the variance on A. Okay? And then we got to square root that. So we got to take 12 times 1.5 squared. Okay? And that new standard deviation would look like somebody can check my math, but I'm pretty sure it's 7.79. Okay? Now we can find out what the probability that the sum of the 12 apples is less than 100 ounces. Now I want to know what the probability that Z is less than 100 ounces is. Right? That's where you go back into your normal curve. And this curve is going to have a mean of 108 and a standard deviation of 7.79. Right? And this is where you just do your normal calculation stuff. Right? I'll save you the shading and whatnot. If we do normal CDF, you should not. You shade, mark your standard deviations. I'm just going to do this for time's sake. Okay? Normal CDF, we want it to be less than 100 ounces. So we go 100 for our lower bound. No, sorry, our lower bound, we're going less than. That's probably why we needed to shade, right? It's going to be this way. Our lower bound is going to be something really, really small. So I'm going to make it negative 100. My upper bound is going to be at 100. The mean is 108, and the standard deviation is 7.79. And when you type that in, you get a probability of approximately 15.2%. And you can verify that with your own calculations. Okay? And that's it. That's all there is to combining. So you have to decide, are you combining random variables or are you transforming one? And you have rules that will govern either one of those two situations. Okay? So that's it for tonight. We'll end here. Homework is attached. We'll get into our binomial and geometric situation starting tomorrow night. Okay? Have a good night. See you guys tomorrow.